solve problem C111 as promised because of today's class. Okay, the video is the problem is set here. And let's write this mathematically. It says the savings is 15%. 15% is 0.15 of the rent. Because 15%, the word itself is saying is 15 of whatever per 100. And if you divide this with a calculator, you get 0.15. And it's saying investment is 30%, 0.3 of the variation rate of y. The variation rate is the speed at which y changes, so this means y prime, or if you prefer, is 0.3 dy over dt. Now from these two we have savings equals to investment, so 0.15 y equals 0.3 dy over dt. And let's move things around. Then we move this guy here, and the y we'll move it to the other side. And what we have here is 0.15 dt equals to 0.3 over y dy. It's a case of separation of variables. For that to be solved, we need to integrate both sides. So before integrating, let me do a little bit of rearrangement. First of all, I will write 0.3 over y dy equals to 0.15 dt. And it doesn't matter really what I'm going to do, but as I did it in class, I'll do it now. This 0.3 will go to the other side dividing. Because here is multiplying, so it goes dividing to the other side, and what I have left is 1 over y dy equals to 0.15 over 0.3 dt. Observe that 15 is half of 30. 30 is twice 15, so 1 over y dy equals to 1/2 0.5 dt. Because like I said, 0.15 over 0.3, that's 0.15 over 0.30, same thing. So this is 15 over 30, which is 1/2 of 0.5. So once we have done that, what we have to do, we have to integrate both sides. And what we get on the left hand side is the integral of 1 over y dy. This should be, really speaking, the log of the absolute value of y. But we're assuming that y of 0 is 4,500, which is positive, so we can peacefully write here simply the log of y. And that should be the integral of 0.5 dt, which is 0.5t plus c. Thus, we have reached that the log of y is 0.5t plus c. We exponentiate both sides, and we have e to the log of y is equals to e to the 0.5t plus c. E to the log of y, this thing here, exponential and the log are inverse of each other. So let me write it here in some color you can see. In red, exponential and log are inverse functions. So that means one does something and the other one undoes it. If there's such words as undoes it. But anyway, whatever one function does, the other one does the opposite. So we have that e to the ln y is equals to y, and that should be equals to e to the 0.5t plus c. Let me write this by the properties, so I'll use a different color. By the properties of the exponential, e to the a plus b is e to the a times e to the b. So here, in our particular case, this will be e to the 0.5t times e to the c. Now, c is a constant, so e to the c, this is simply a constant, a number. So that means we can call it by another thing, k. So this is k times e to the 0.5t. Y is equals a constant to be found e to the 0.5t. How do we find k? Well, using the initial condition, which we have not used, that we started with a value of 4,500. Now you plug in t equals to 0 here, you get this is k e to the 0, e to the 0 is 1, is k. So 4,500 equals to k, and our solution, depending on time, is 4,500 e to the 0.5 t. That for the solution. What about the long-term behavior? The long-term behavior, this means simply what happens with y when t goes to infinity. Positive infinity, the time goes to the long term, meaning to infinity. Positive, so t goes to positive infinity, half of t will also increase to positive infinity, and e to the positive huge number, positive infinity, is positive infinity, is infinity. So this means y goes to infinity. The rent increases as the time increases.